Hi all, welcome to i-tutor Academy. Today we will discuss about Unit 5 subsection 6 of Mmpc 009, that is line balancing method. So Kilbridge and Wester method. In this procedure proposed by Kilbridge and Wester, numbers are assigned to each operation describing how many predecessors it has. An operation with the lowest predecessor number are assigned first to the workstation. The procedure consists of the following steps. The first one is construction the precedence diagram for the work elements in the precedence diagram. List in column 1 all work elements that need not follow others. In column 2, list work elements that must follow those in column 1. Continue to other column in the same way, and by constructing the column, the element within a column can be assigned to workstations in any other provided all the element of the previous column has been assigned. Next is select a feasible cycle time CT. By a feasible time, we mean one more which. So this is the equation for that. Okay, so this one. And assign work element to the station such that the sum of the elemental times does not exceed the cycle time, that is CT. This assignment proceeds from the column 1 to 2 and so on, breaking intra-column ties using the criterion of minimum number of precedents. Delete the assigned element from the total number of work element and repeat step 3. And if the station time exceeds the cycle time CT due to the inclusion of the criterion work element, this work element should be assigned to the next station. And repeat step 3 and 5 to until the element are assigned to workstations. Okay, so example 7.2 is here and solution also here. Figures are there in solution and table is here, so please go through it, and based on equation there is solution also. Okay, and Helgens and Birney method, that is ranked position weight technique. This method proposed by Helgen and Birney, also known as the ranked positional weight technique. It consists of the following step. The first one is develop precedence diagram in a usual manner. Determine the positional weight for each work element and rank the work element based on the positional weight in step 2. The work element with the highest positional weight in ranked first, and proceed to assign work element to the workstation where element of the highest positional weight and rank are assigned first. If any workstation additional time remain after assignment of a operation, assign the next succeeding ranked operation to the workstation as long as the operation does not violate the precedence relationship and the station time does not exceed the cycle time. And repeat 4 and 5 until all elements are assigned to the workstation. So example is here, and please go through it, and solution also there. Example 7.4, design assembly line of cycle time of 10 minutes for the following 10 work elements is here, and figure is here. So please go through this so you will get more idea with the example. Next is linear programming method of line balancing. Assume that a job is broken down in 6 elements task and the total duration of all such a task is 30 minutes. The cycle time, the length of the time available to workpiece is on each workstation in 10 minutes. Thus the minimum number of stations required 30 by 10 is equal to 3, and maximum number of workstation may be 6, that is equal to the number of tasks involved. So this is the precedence diagram. Okay. The problem now reduced to find out the exact number of workstations needed and which task will be assigned to which station. And figure shows the type of constraints equation, namely cycle time constraint, step or task constraint, and precedence constraint will be formulated to solve the problem like an assignment model. And next subsection is problems and prospects of mass production variable work element time. In both the line balancing method discussed in the previous section, it was assumed that the work element time are constant. In practice, this time may be varying randomly owing to factors like human variability, fatigue, or carelessness on the operator's part. Even in case of machine operation, the setup or positioning time of the part or component could lead to random variation in the individual work element time. And since the assembly line is balanced for a given fixed set of work element time, and effect of this variable are twofold. And the greater idle time at some workstation and the reduction of the average production rate of line. And in designing line of random work element time with the given means and variance, some modification of the domestic line balancing method is adopted, utilizing the additional criterion that the probability of the station time exceeding the cycle time should be kept as low as possible. Some method of probabilistic assembly line balancing are discussed by Elside and Bosch. Breakdown at a workstation. The mass production system consists of a number of stages in a series at which some operations are being performed. A failure or a broken of one stage or workstation will result in failure of the entire production system until repair is completed. The result would be decreased production rate, and this problem is handled in practice by providing. And first one is efficient maintenance service, so that the broken down units are repaired and put into service as soon as possible. Buffer storage of semi finished goods between each pair of stage, so that the entire line does not stop due to the failure of one or more units. The question of how much buffer storage to allocate between stage is of great practical importance. A higher buffer stock means greater tied up capital but a lower risk of runout and subsequent line stoppage due to breakdown. The decision is estimate the size of the buffer can be governed by one or more of the following criteria, which consider as to what is the buffer size that and maximizes the production rate of the system and minimizes the total production cost. The maximize the availability of the production system. The problem could in general be viewed as a multi-stage queuing system, and the C for the instance Elasier and brochure. This is an assembly line with a buffer as a multi-stage questioning system. And multi-product line, one of the major disadvantages with assembly line is their relative inflexibility. A line is usually designed for one product, and changes in design of the product are often difficult to accommodate on the line unless suitable adjustments are made at a workstation. But when similar product in which a large percentage of the tasks are common have to be manufactured, the possibility of the same production line for the products can be explored. Since the tasks are fixed with the stations, once balanced, it should be apparent that station time and efficiencies will vary with the products being produced. A great variety in these efficiencies might dictate that separate line be utilized, and in case a multi-product line is to be designed, a common precedence diagram must be developed. So A, B, C. These are the precedence diagram for two product line, A product 1 and B is product 2, as next is combined one. And for instance, the precedence diagram for a two product case figure 10 for cycle time of 10, the optimal. So here is figure 10, 11, and workstation assignment for the two product assembly line is this. So please refer your Ignou study material. And the next subsection is 8, that is modular production and group technology. One criticism of manually operated assembly line has been that they reduce a man to a mere cog in a machine. Surely you can imagine the boredom. So monotony and fatigue of a man who spend all his time tightening the same bolt on a part in an assembly line. And it has been found valuable to enlarge the scope of work of the workers so that he assembles a complete module, which in turn may be used assembly line to assemble a product or a number of different products sharing that particular module. And next is operators a sense of accomplishment for assembling a complete module. In modular production, we tended to specialize in the production of particular part or activities that can be that can then be included as component of more than one product or service. The reason for wanting to achieve such a commonality is that one part or operation, if used in several products or service, can accumulate sufficient demand volume to warrant investment in a flow show. Group technology provides another aspect of the same basic idea. It refers to specialization in families of similar parts. Hence, components requiring primarily turning operations such as shaft are collected in one group, while component requiring surface grinding and drilling operations such as plates are assigned to a different group. And these groups become the basis on which a traditional process plant layout can be reorganized into a group technology plan layout in which machines are arranged in such a way that each machine is assigned to production of only one group of parts. Group technology typically affect only component manufacture, not the assembly stage of production. And next is automation and robotics. Mass production has been assisted to a large extent by automation and robotic in the recent past. Automation refers generally to the bringing together of three basic building blocks, that is machine tool, material handling and control. And often a considerable amount of time is spent to load machines and unload work and to convey it between the single operation machine. This restriction has been partly relieved by the development of a multiple spindle machine. With the machine, a single motor drive several spindle uh, through a gear train allows multiple operations to be performed by one machine. And industrial robotic, as defined by the Robot Institute of America, is a programmable multifunctional manipulator designed to move material parts, tools or specialized device through variable programmed motions for the performance of a variety of tasks. And what separates an industrial robot from other type of automation is the fact that it can be reprogrammed for different applications. Hence, a robot falls under the heading of flexible automation as opposed to hard or dedicated automation. Industrial robots consist of three basic components. The first one is the manipulator or arm, which is a series of mechanical linkage and joint capable of movement in various directions to perform the work task. And the controller, which actually directs the movement and operations performed by the manipulator. The controller may be an integral part of the manipulator or may be housed in a separate cabinet. Third one is the power source, which provides energy to the actuators on the arm. The power source may be electrical, hydraulic or pneumatic. And major reason for use of robots in industry are increased productivity, adaptability, safely, ease of training, return on investment and greater reliability. Robots are currently in operation in welding and assembly, drilling and routing, inspection, material handling, machine loading, die casting, and a variety of other applications. Summary. In this unit, we have presented the concept of mass production, which essentially involves the assembly of identical or interchangeable part of component into the final product in stages at various workstations. The relative advantages and disadvantages of mass or flow production are discussed and conditions favoring the installation of such a system are identified. How to design an assembly line starting from the work breakdown structure to the final grouping of tasks at a workstation is also discussed using two commonly used procedures, the Kilbridge Western heuristic approach and the Helgeson-Briney approach. Various problems with the assembly line, including variable work element time, breakdown at two workstations, and multi product line, are discussed. The concept of modular production and group technology has also been touched to indicate how flexibility can be reduced in mass or flow manufacture. Finally, the role of automation and the use of industrial robots in mass production has been discussed. So keywords are here. So if you feel any words are difficult, you just refer this section. So the explanation of each word is here. Okay. And self-assessment exercise also, this is like your assignment, must do it because it will help you for your term and examination. So it's around there is 7 questions are here. Please try to do it. Okay, in between any doubts you can contact us anytime. So this is about today's section. For more MBA videos, you just do like, share and subscribe our channel. Thank you so much.
i-tutor Academy presents Ignou Mba complete syllabus coverage classes for individual students, semester-wise subject with online and flexible timing. For more details, contact on +916 238 217 885.